Good afternoon, guys. My name is Julie, and I will supposed to share one of our design to solve a specific problem restarting our database without the API restart. So here are my short talks agenda. There are several things, so we will take a look what is the problem of this technical design, and I will show what we have to do to solve that. And then also we'll introduce several cases what we did with this design. I am one of the member of OpenChat backend service team. As the messenger service in East Asia, Line has a really one interesting traffic pattern. As you can see from this graph, we have a huge and a sudden spike on the first day of every year. This sudden spike becomes more than 3 times as usual. So we have 2 months of special work, and we call it a New Year preparation. To cover this sudden spike traffic, commonly we add more API servers for the bigger traffic. That means we have to prepare the bigger capacity of our API servers at the first. However, unfortunately, sometimes we face the problem that the bigger capacity cannot promise us. I want to call it the database outage. There are several destinies from the database outage. The first thing is sometimes one of your storages become totally unavailable, or you want to add more servers to prevent the case. For them, so what are you supposed to do that? This slide shows the several steps what we'll have to do for these operations. First, preparing new databases, update the new endpoints on the properties, deploying to API servers, and then wait. Of course, you can do the next step of restarting concurrently. However, it is not changed that you have to wait all API servers has already done to restart. After all the steps, you can monitor the new configuration work as you expected or not. As this step shows, there are several duplicated steps, wait and wait. As I showed what the problem we have, the number of servers grows as the more users we have. That means we have to wait a longer time for deployment and restarting API servers. And sometimes I feel really bored for these operations, so I want to really resolve this situation. Let's get back to these steps. I highlighted the 2 main points, deploy and wait, restart and wait. So what is the next word without these 2 steps? From now on, I will show one of our technical design to resolve this, the longer execution time. Here is a naive approach. It starts with a simple idea that let's put the database configuration not in the API server, but on the remote somewhere. For this, we chose the remote coordinator to manage the database configuration, which can be fetched to the API server directly. Then let's take a look deeply. Yeah, for us, we use the Myscale for our data storages. And then to offer the connection on the API server, we use a Hikari connection pool. As a remote coordinator, we introduced a Zookeeper, which one is really famous for that purpose. In the application side, we use the curator Zookeeper client with a special recipe. The recipe we used is a watcher, which can be notified about every change on the Zookeeper cluster, as all of you already know. Then let's take a look how can we do the same operation I mentioned before. The starting point is the same, just preparing new servers for our new storage. Then when you update on Zookeeper, the curator client will be notified automatically on the API server. And then the connection pool can respond about this change, either create or close the MySQL connection pool. Yeah, it is. So let's take a look back how these steps will be changed with the new technical design. Yeah, becomes so simple. Just 3 steps we have to do. Preparing your servers, update a new database configuration on the Zookeeper, and then monitoring. Really, the connection point is closed and opening as we expected. From now on, I will show what we did before with this technical design. The first thing is master failover. As I told you in the previous slide, sometimes we met some unresponsive storage database. At that case, we have to replace it with a new server, which can be working as usual. Then we use this the technical design to replace the outage servers to the new server. The second case, adding more shards in our storages. For the bigger capacity, it is a common way adding more servers for the bigger data. So we can use this technical design by adding new servers, just updating the configuration on the remote coordinator simply. The other topic is dynamic slaves. Our service traffic becomes bigger or less just in case. Then if you want to cover more traffic, then you can add more servers easily. However, if the traffic is less than before, you can remove them also easily. Yeah, so let's go to the conclusion of the last part of this talk. I briefly describe again how we can do the previous database operation with this new technical design. So that the point is the operation time becomes really shorter than before. Throughout our experiences, it takes less than 5 minutes. Also, unlikely to before, the number of servers is totally regardless of the operation time. So you can keep your time for your database operation with this technical design. Also, the shortened execution time implies that you can recover from database outage in the shorter time than before because you don't need to deploy and restart API servers. Yeah, we are almost done. So I want to all of you guys can be free from the database operation time. Do not be late from your work. Thank you.